on the GRE, on the GMAT, any advanced test, whether you're applying to business school, grad school, you're going to see fractional exponents, especially in the harder problems. Let's start off by just doing a quick review of what to do when you're multiplying two things that have exponents. If I have a squared times a to the third, that's going to be just a times a times, that's a squared times a times a times a. And that's going to equal a to the 1, 2, 3, 4, 5, so that's going to equal a to the fifth. Now notice that this is the same as adding the exponents of the previous thing. In other words, a to the 2 times a to the 3 is a to the 2 plus 3, or a to the 5. So if I'm multiplying these exponent things, I'm actually going to end up adding the exponents. That's going to turn out pretty handy if we want to figure out what, for example, 9 to the 1/2 is. Like, what does that even mean? Well, it's hard to figure out exactly what it is, but we can do this. What if I take 9 to the 1/2 times 9 to the 1/2? Now, remembering the previous rules, the base stays the same. We get a 9 to the 1/2 plus 1/2, and 1/2 plus 1/2 is 1. And 9 to the 1 is just 9. So we know that 9 to the 1/2 times 9 to the 1/2 equals 9. So we know there's something times itself equals 9. We say there's some number multiplied by itself that equals 9. What could that number be? Well, we just think about it for a while and we realize that 3 times 3 equals 9. Or in other words, 9 to the 1/2 equals 3. Now, let's see if we can figure out some general principle that applies here. What if we do 36? Oh, whoops. What if we do 36 to the 1/2? 36 to the 1/2 is just some number such that, let's say I do 36 to the 1/2 times 36 to the 1/2. That equals 36 to the 1, which equals 36. So I'm basically saying there's some number times itself that equals 36. And what number is that? It's 6. But what's that general thing? What do we call a number such that if you take that number multiplied by itself, it gets the original number? It's just the square root. The square root of 36 times the square root of 36 equals 36. Why? Because that's the definition of what a square root is. You do that with any number. Square root of 17 times the square root of 17 equals 17. That's just what the word means. Now, 36 to the 1/2 and square root of 36 seem to be acting really similarly. You know why? They're the same thing. 36 to the 1/2 is the same thing as the square root of 36. In fact, anything to the 1/2 is the square root of that thing. So if I do, say, 25 to the 1/2, that equals the square root of 25. I can do 11 to the 1/2, that equals the square root of 11. Now, sometimes it's not 1/2, right? You could have 2/3 or 1/3 or all kinds of different things. Let's just do an example there. Let's say I have 8 to the 1/3. Well, here's a fact. 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3 equals, we're going to add these up, 1/3 plus 1/3 plus 1/3 is just 1, equals 8 to the 1. In other words, 8 to the 1/3 is some number that times itself, times itself, times itself is equal to 8. The number is 2. So we know that 8 to the 1/3 equals 2, and that's not called the square root anymore, it's called the cube root. It's the number that if you cube it or multiply it by itself 3 times gets you the original thing. So that's the quick introduction to fractional exponents. You're going to work with the negative fractional exponents, all kinds of different things. As they get more advanced, the problems will get more difficult, and you'll have to really try a few things out to make it work. But here's the basic idea. Stick with these basic ideas. Make sure you understand them. Watch this video a couple times if you like to, and you'll see how much easier it makes some of the hardest problems on the GRE and on the GMAT.